All right, so in section 6.4, we're going to be dividing radicals. Now, they're not supposed to be very difficult to do, but there are some that start to look a little weird. There is one rule that you guys have to know is that you cannot divide by radical functions. So we're going to have to do what's called rationalization, okay, at some point. So I'll show you how to do that stuff when we get to it, okay? So a couple of notes before we get started. Okay. So first thing you guys need to know. No square root in the denominator. Okay. You can't have square roots in the denominator. So what do we do if we do have a square root in the denominator? Well, sometimes you can just simplify it and it'll go away. Other times it won't. So let me give you an example of what I'm talking about. If I give you the square root of 8 over the square root of 2. Now, they are expecting you guys to remember some stuff from Algebra 1. So right now I'll write those things in case you didn't remember. But just so you know, if you have two square roots, one on top of the other, you can rewrite it as one big square root. Like that. Okay? And 8 divided by 2, well, that's 4. And the square root of 4 is what? 2. And you're done. Notice how there's no square root in the denominator. There's not even a denominator, right? So sometimes you can get rid of the square roots by just simplifying the problem. Okay? Other times you can't. So, if I give you a problem like this, notice that problem I can't just put into one big square root. The reason is there's no square root on top and on bottom, just on the bottom. So what we have to do is called rationalize the denominator. Rationalization means you get the thing that's causing the problem, which would be the radical 3, and you're going to multiply top and bottom by that. The thing that's causing the issue, you're going to use it to fix the problem. Okay? Well, 2 times radical 3, we did multiplication of radicals, right? That just becomes 2 radical 3. Radical 3 times radical 3 is radical 9. What's the square root of 9? On the bottom. 3. So there's your answer. Notice square roots are gone from the bottom. Okay? So there are ways for us to get rid of things. Now there's this other thing called conjugation or conjugates, but we'll get to that when it's time. Okay, we're not going to do that right now. So remember, we could try to simplify first. Maybe we can get rid of the radical that way, or we may have to multiply by the denominator on top and bottom. Okay, so we'll see that right now. So check this out. Now we're going to work on question number 2 together, okay? But I just want you guys to notice something on question 1. I know it says square root of 8 over square root of 12, but you see how they both have a square root? So my advice to you is to write it into one big square root and simplify. That might actually help you do the work faster, okay? So I'm not going to do that for you, but I'm giving you your hint, okay? Combine it into one big square root and simplify. And you should see that you should be able to do something with it. Now, oh, by the way, I forgot to tell you this. Right now that I thought about this. Let's say you had like a 9 over 12, like a square root of, well, we'll do this. Let's say you had something like this. Okay? And you're like, well, let me combine it. So I do this. And you say, okay, I'm going to simplify it. So 10 over 12, you can reduce it by 2. That becomes 5 over 6. Oops. But that doesn't have a nice square root. So how do you fix it? Once you have, when it was broken apart and you put it into one big square root, you can break it apart again. So you can do it like this. And and this is a good answer, but right now you're going to know, like your books would say, oh, this isn't right. What's wrong with it right now? What looks wrong with it? The what? Yeah, in the denominator, right? The square root of 6 shouldn't be there, right? That's why I kind of zoomed out to show you the thing in black. No square roots in the denominator. So what would you do? Well, I kind of showed you that in example 2 right there. Multiply by the thing that's causing the problem. Okay? Square root of 5 times square root of 6, that's square root of 30. And square root of 6 times square root of 6 is the square root of 36. What's the square root of 36? Alright, so that's radical 30 over 6. And that's your answer. Okay? There's a lot of little tiny steps, but they're not like insanely difficult steps, just little tiny steps you have to work with. So you can get two square roots, put them together, simplify, then break them back apart, and then start to rationalize. Okay, that's something that can happen. You're going to have to do that for question 1. Okay, you're going to have to break it apart and rationalize. Okay, question 2, let's go to that one. So, can I combine the numerator with the denominator in question 2? Well, the top doesn't have a square root. So I can't just make one big square root. I can't just do that. So what do I do? Well, let's see. Since I can't do this, okay? Not allowed. Because the top doesn't have one. So that's not good. But I don't want that square root of 5 on the bottom. So what do I do? Starts with the letter R. Yeah, rationalize, right? Rationalizing the denominator means get the problem, which is the square root of 5, and multiply by the thing that's causing the problem. So the top will be 5 square root of 5 over the square root of 25. Well, we know the square root of 25, that's 5. And notice I can actually cancel 5 over 5, right? These will go away. So my answer is just square root of 5. See, these problems, they're not meant to be like super difficult, but they can be a little tricky sometimes based on how you have to work it out. And like I said, near the end, we're going to do some problems called conjugates. Those can get a little tricky, all right? But they're not that difficult. It's just you have to know what to do if you see them, right? Just like right here. I have to know that, oh, I can't have a square root in the denominator. Let me multiply top and bottom by it, okay? Any questions on number 2 here? Remember, for number 1, combine them into one big square root, simplify, and then break it apart, okay? And you should be able to find your answer pretty quickly from there, all right? So, all right, let's go to, notice number 3, I would tell you to do the same thing. Combine them, okay? Because 4 and 12, they're both in square roots, but 4 and 12, they can reduce each other. So I would tell you combine them and reduce. Okay? But number 4, a little bit harder. So we'll go over number 4. So 4 radical 5 over 2 radical 3. The very first thing I would do, after I write down the problem here, 4 radical 5 over 2 radical 3. I'm going to reduce 4 over 2, that's 2 over 1, right? I can reduce that. This will become a 2. This will become a 1. So this basically is 2 radical 5 over radical 3. Can 5 and 3 be reduced if I combine them together into one big square root? No, right? 5 doesn't get divided by 3. There's no number that goes into both 5 and 3 other than 1, but like we always say, 1 is kind of useless for us. So, since I can't combine them, but radical 3 is a problem, then what do I multiply the top and bottom by? Well, not just 3. Yeah. Radical 3, right? That's the issue, right? The square root portion of it, right? We're not supposed to have radicals in the denominator. How do we fix it? Multiply by the problem, right? If this is the problem, multiply by the problem on top and bottom. So here we go. The top becomes 2 radical what? 15, thank you, over radical 9. And square root of 9, we know that. That's going to be a 3. Okay? And there you go. We're done. So just remember that thing that I wrote for you guys. You cannot have square roots on the bottom. Okay, no type of square root on the bottom. So you're going to have to get rid of it. The way you get rid of it is by multiplying by the problem, right? The square root that's on the bottom. Square root of 3 over square root of 3 in this case. And that helps us get rid of the problem. So I think I told you guys the reason why they don't want you to do this is because many years ago, calculators could not divide by radicals. You couldn't divide by the square root of 3. Your calculator would give you errors. So they said, well, we got to fix it. We have to make it so that they don't ever get an error. So how do we do that? Well, we rationalize it, right? Now, if you have a newer calculator, you can divide by like square root of 2, square root of 5. It doesn't have a problem. Okay? So, but this rationalization came up because of the fact that calculators weren't able to do it before. So now we have to learn how to do it by hand. All right? I'm just checking number 5 really quick. So number 5 is kind of just like the one we just did. Okay? So don't get freaked out by it. Same type of problem. You're going to reduce and combine if you want to. Okay? So maybe what I'll do is I'll do number 5 for us. And because 6 is kind of like one that we just did right now. So let's do number 5. So this one's a little different. Now, you should notice that there's 2 5s on top and bottom, right? So you can get rid of that. All right, so let me go ahead and rewrite this. Radical 3 over radical 15. Now at this point I say, all right, 3 and 15, I could reduce that. Let me put it into one big radical. That becomes 1 over 5. Well, now that I did that, let me break it apart again. So there you go. What's the square root of 1? That's just 1, right? So that's equal to 1 over square root of 5. Now that looks great, but there's a problem. What's the problem? The denominator is an issue. So we got to get rid of it, right? We got to rationalize it. I'm doing this in a big long line. But it's okay. We're not doing question number 6 here. So when I do that, I get radical 5 over radical 25, which is radical 5 over 5. Okay, you know what? Let me put a box around this thing. By the way, I cannot cancel those 5s. Sometimes some of my students will be like, oh, this goes away, that goes away. You can't. One is in a square root, one is not. So you can't just get rid of them because of that. I'm going to go to the other answers really quick. Let me just box those really fast. You can see why I like doing the even problems. That way I don't run into that problem where I'm leaking into question 6, right? By just going sideways there. All right. Now, these next ones, these are not what we're going to call conjugates yet, okay? That's not it. Okay? So don't worry. The 9 and 10 are conjugates, so we'll get to those soon. But let me show you 7 and 8 are pretty much the same idea. Let me show you how to do these. So 3 minus 3 radical 2 over 3 radical 5. Now you guys notice how there's 3's everywhere. There's a 3 all by itself minus a 3 radical 2 divided by a 3 radical 5, right? You can actually reduce. This will become a 1. That'll become a 1. This will become a 1. Because you're basically just dividing by that. You're dividing by a 3. Okay? If you don't like the way I did that, let me show you another way. And you can just watch that. Let me show you another way you can do it. Sometimes students would rather see me factor out. And then they feel comfortable canceling out. So it just depends, right? Depends how your brain wants to capture it. So some people want me to factor the number they have in common out and then cancel it out. All right? So here we go. This is what I have now. 1 minus radical 2 over radical 5. Well, again, the problem is I have a radical in the denominator. So the way I get rid of it is by multiplying top and bottom by that radical. The only difference now in terms of what we have to do is, remember before we would just multiply a number times a number on top? Here I'm going to have to distribute, okay? This is going to go here and there. Okay? So, 1 times a radical 5 is a radical 5 minus radical 2 times radical 5 is radical 10 divided by radical 25. Well, what's the square root of 25? 5. So my answer is radical 5 minus radical 10 over 5. And you guys can see that's option C, I think. There you go. It's not that much harder. It's just like a little extra step you're going to have to distribute. That's all. Are we okay with this one? The next one is a little weird. But thankfully there's only 2 and I'm going to do one of them for you. So you're just going to have to worry about one more. So again, multiply top and bottom by what's causing the problem. Okay, that's the key. Now, why did I say the next ones are a little weird? Well, check them out. Notice how this one doesn't just have one term on the denominator. It actually has 2 terms. So I got to talk to you guys about a conjugate really quick. It's not a lot of teaching on the side. It's just a real quick thing. Conjugates. Now, if in the denominator they gave you something that said A plus B, okay, then the conjugate is A minus B. That's what you're going to multiply by. If the problem had an A minus B on the bottom, then the conjugate would say multiply by A plus B. It creates a little weirder multiplication, but it's just, that's all you're doing. You're just multiplying by the opposite sign. Okay? So, that's all we're doing. Changing the sign, okay? Now, look at the problem here. Let me write it out. 3 minus radical 3 over 2 minus radical 3. You see how I have two terms on the bottom? Okay, 2 minus radical 3. In order, and I'm not supposed to have square roots on the bottom, but there's an addition or subtraction down there. So what I need to do is multiply by the conjugate of 2 minus radical 3. The conjugate would be 2 plus radical 3. I mean, that's not hard to write that. The tough part is being careful when you now distribute your work, okay? Just be very careful. So here we go. Let's do the top first. 3 times 2 and 3 times radical 3. So I get 3 times 2 is 6 plus 3 times radical 3 is 3 radical 3. So that's the first part. Now let's distribute the negative radical 3 on top. So negative radical 3 times 2, negative radical 3 times radical 3. So again, be very careful with this. It gets messy. That's why I'm just going slow. Negative radical 3 times 2 is a negative 2 radical 3. Negative radical 3 times radical 3 is a negative radical 9. We can simplify, okay? But we'll do that in the next step. All right, now for the bottom. Okay, so I got to do it again, right? So 2 times 2 and 2 times radical 3. 2 times 2 is 4. 2 times radical 3 is a positive 2 radical 3. And then do it again with the blue lines right there. Negative radical 3 times 2 is negative 2 radical 3. And negative radical 3 times radical 3 is a negative radical 9. Again, just be very careful, be patient, take your time, because if you mess up, then you got to do it all again. So better to do it right the first time. Right? So just take your time. Now, the 6 on top is going to stay there. 3 radical 3 minus 2 radical 3. This part right here, what does it become? They have the same radical. 3 minus 2, 1, right? So it's just positive 1 radical 3, or just positive radical 3. And then minus what? 3, right? Yeah, because that's what the square root of 9 is. All right. Now let's do the bottom. 4. 2 radical 3 minus 2 radical 3. What is that? What happens there? It cancels out. Thank you. That goes away. By the way, that always happens whenever you multiply by the conjugate. The middle always goes away. So a little trick that I tell people, all you have to do is multiply the first terms. So like, you just multiply these terms and these terms. That's all you really have to do. But, you know, if I were you, I'd still just kind of work it slowly. So, all right, it cancels out, and then minus 3. So, 6 minus 3 on top is 3 plus radical 3 over 1. Or just 3 plus radical 3, which is actually D right there. So that's using a conjugate, okay? So whenever you use a conjugate, like I said, it's going to look something like that, really weird, right? It's going to get very complicated. Just draw lines so that you know what you're doing, right? Work your problem slowly so you don't get lost, all right? And then just simplify little by little, okay? Take your time.